discussion on thermal conductivity gauge, nothing but Pirani gauge, how it is going to measure low pressure measurement. That is what we are going to see. So when you are talking about thermal conductivity gauges, what is the meaning of thermal? Thermal, which is nothing but heat. Conductivity in the sense it is like an exchanging nature. That is your conduction from one place to another place. That is what thermal conductivity. In thermal conductivity gauges, it consisting of two types, thermocouple as well as Pirani gauge. What are those two gauges? These two gauges are used for measurement of low pressure and ultra high vacuum. So for low vacuum, then we have to go into Pirani gauge. For ultra high vacuum, then we have to go thermocouple gauges. Why low vacuum pressure is important? Yes, low vacuum pressure measurement is very much important in metallic industries. That is the reason why they are going for low vacuum pressure measurement. For low vacuum pressure measurement, they are depending on Pirani gauge, and both are working on the same principle of detecting thermal conductivity of the gas by the change in temperature. So thermal, just we are going to detect the heat. In thermocouple gauge, the temperature is sensed by a thermocouple, and in Pirani gauge, it's by the change in resistance of the heated wire. So heater wire, which is nothing but a filament. So for low vacuum measurement and ultra high vacuum pressure measurement, they are going thermal conductivity gauges. So I would like to tell you something. Here you can just look at the diagram. There are two boxes I have given. The first one is, it is an object A and this is an object B. So when the amount of heat which is passing through the object A, and there is an heat release, that was Q1, and the object B, Q1 is applied and Q2 is absorbing. So how much amount of heat is going to generate to these two objects? So I have taken for the Q1, that is the amount of absorbing heat of the first object A, which is greater than the object B. That means what? Your object A, it consumes more thermal energy. So the conductivity is very less in your B. This is what thermal conductivity. What is electrical conductivity? I am just taking two conductor and I am just applying the current through which the conductor A and through which the conductor B. And here the current generated for the conductor B is more current. So I2 is greater than that of I1. Then that means there is then electrical conductivity, your B, that is the conductor B, which is greater than your conductor A. That is what the difference between thermal conductivity and the electrical conductivity. Move on to this. While you are talking on this thermal conductivity, how they are measuring. So thermal conductivity is measured using the Greek letter lambda. What are the formulas they have used, which is nothing but watt divided by meter into Kelvin. That is what the units they are used for thermal conductivity. But how the thermal conductivity varies when you are talking on metal and the plastics. So if you are taking two things, one is metal and the plastic, both are different, right? But how the thermal conductivity nature could be. The first one is, you have a bulb and the heat is liberated. So heat is generated, which is passing through a metal. And the second one, the same thing, which is passing through the plastic. So you can just look at the nature, look at the structure of both metal and the plastic. In the metal, it consists of some like a nature. It is like some cubic nature or structure. So there is an how the coupling of atom is forming and how the bonding nature it could be. So when you are looking at, there is an organized structure, but in plastic it is controversy. It is not so. It doesn't have an organized structure. The molecules are independent of each other. So there is no structure format is there. So what will happen? Just look at here. Because when the heat is passing through the metal, this dotted one I have chosen, those dotted one, it is getting the heat is absorbing and the heat is getting liberated. So more amount of energy is getting transferred, and the energy transfer, it will be fall on to the neighbor one also. So what will happen? There is a vibration. That is what I have indicated as a circle. So due to this vibration, it is passing to the next one, next, like that it is moving. So what will happen? Automatically the energy transfer due to vibration is very much higher when you are talking on metal. But in plastic it is not so. Your vibrant energy, it is getting lost because of no organized structure. So automatically the energy transfer, it is getting into a slower rate. That was the difference for the thermal conductivity nature of metal as well as plastics. So that could be the understandable one. Whatever the vessels we are using in the kitchen, that was the best example when you are talking on the nature of your thermal conductivity. So moving on to the another example. Here I have chosen three medium. The first one is atmospheric medium. I have taken air. Second one is cool temperature, and the third one is hot gas. So when you are looking at the atmospheric and the medium is air, when I am just taken as a conductor, one wire, and the wire I am just passing on the heat. So you all know Q, which is nothing but I squared RT. So your heat is depends on the amount of current passing through the wire and the conductor, which consists of a resistant, and how much time it is going to take. So that is what the equation Q is equal to I square into RT. So when the first medium, it is an air. So automatically what will happen? When the heat dissipation is related to your amount of resistance and the amount of current. And the second one is cool temperature. Cool temperature with a medium of high density, high pressure. So if it is in cool temperature, automatically what will happen? Already the heat is absorbing, it will be getting liberated. So automatically your temperature will getting into decrease. So if the temperature is getting decreased, automatically the resistance also low. The third one, if the medium is hard gas, so the temperature will be higher. But the medium I have used is low pressure. So automatically if the temperature is increased, the resistance will be higher. That was the examples of those three medium. This is the same principle they are using in the Pirani gauge. So what is Pirani gauge? Your Pirani gauge is a measurement of very low vacuum pressure measurement. But here using this Pirani gauge, we are going to measure a low pressure. So how it is happening? It is nothing but the surrounding pressure changes the filament temperature, by which the resistance also change. At a lower pressure, the effective thermal conductivity of gases decreases with the pressure. So it's a device measure the pressure through the change in thermal conductance of the gas. So it consisting of, you can just look at the diagram. This is what called Wheatstone bridge. So Wheatstone bridge is working on the principle of null deduction. That is nothing but bridge balance equation. So bridge balance means it is nothing but the opposite arm. That is the potential difference. Upper portion and the down portion both should be equal. Then only you can get the detector we have used is in galvanometer. If the galvanometer shows 0, then it is an null indication. That is what call it as in galvanometer principle. So here the Pirani gauge chamber which encloses a platinum filament. Here you are having two things, that is your unknown vacuum and the compensating coil. So your filament, which is nothing but platinum, or you can use tungsten also, and it consists of a compensating cell, that is only because of minimizing the variation caused due to ambient temperature, and the compensating cell as well as the applied pressure, that is nothing but the unknown pressure, both are kept it on your Wheatstone bridge circuit. The Pirani cage is a type of thermal conductivity, and here we are using the metal filament as platinum or tungsten, and which is evacuated, which is consisting both are placed on the glass tube. The connection is either by ground glass joint or a flanged metal conductor sealed like an O-ring, and the filament is connected to an electrical circuit. After calibration, the pressure is taken. So the conducting wire is getting heated, automatically there will be a flow of current. So if there is a flow of current, actually one compensating Pirani cage, Pirani cage, and the another one is open end. So due to environment, automatically there will be a change in pressure. So if there is a change in temperature, automatically there will be a change in resistance. So the resistance can be able to measure using this Wheatstone. So as the gas pressure is reduced, the number of molecules falling proportionality in the conductivity of the surrounding medium will also getting into fall. So the wire will last the heat more slowly. So this heat lasts in an indirect indication of the pressure. So the electrical resistance of the wire varies with temperature. Automatically the resistance will give you the temperature of the wire. So the change in resistance of the filament is determined using the bridge. So this change in resistance of the Pirani cage filament becomes a measure of applied pressure when it is calibrated. So this is what the inside the element, heated element, it is not a single one. There will be a 4 coil inside. Those things are made up of platinum and which will be connected to the bridge circuit. So here in many systems, they are using the formula I square R. It is used for the measurement of 0.5 tar to 10 power minus 4 tar. That was the application of this particular Pirani cage measurement. And if the same thing for low pressure measurement, other than this instrument, one more instrument we have, that is called it as an penning gauge. And what are the advantages? They are inexpensive and more accurate. The pressure reading is wider and faster response to the change in pressure, and the possibility of the process control and the remote reading. The disadvantages of this Pirani cages, the calibration is non-linear. Non-linear means you will not get a proportionality variation. So for if the gas is varying, then automatically there will be a change. That is the reason why we can say the calibration is non-linear, and it requires a calibration against some pressure standard. So before getting into the process, it should be calibrated. So you will not get a better transient response, because transient response in the sense it is in time dependent. So each time if it is not working properly, then you can't able to use it for all the application. Then operation, it requires electrical power, because it is more depends on the heating nature of the filament. That was the disadvantages of your Pirani cage. And moreover, when you are talking on this Pirani cage, you should have a little concept on your Wheatstone. Generally, this Wheatstone bridge is used for the measurement of resistance. So what we are actually doing is, you are just measuring that resistance based on the pressure calculation is happening. So we are going to measure low pressure, but the variation is depends on the temperature. The temperature variation will give you the quantity is resistance through which you can able to measure the pressure. That is what I have instructed on those 3 medium, from which I think you could understand. So if the temperature is according to the temperature variation, you can able to measure the resistance, but the temperature variation is again depends on the medium of the pressure. That is very, very important. So if the pressure, that is high pressure, then your resistance is low. If low pressure, then the resistance is high. That is what the main working principle of your Pirani cage. So this is how they are measuring the low pressure measurement using Pirani cage. Thank you.